3.3 is on domain, range, and functions. So domain and range is something that you probably have talked about in previous classes, but our goal today is to identify what the domain is, what the range is, what a function is, and how these three pieces tie together. How do we use the domain and range to identify if something is a function? So before we start talking about functions, we're going to talk about the idea of a relation. And a relation is just a set of ordered pairs, or a relationship between two things. There are relationships between boyfriend and girlfriend. There are relationships between peanut butter and jelly. There are relations all over in the real world. And in math, we're talking about relations between sets of points. So, for example, scoring in a track meet, first place gets 5 points. That's a relation. So that's saying that first place gets 5 points. Second place gets 4 points. Third place gets 3 points. Fourth place gets 2 points. So we could express this relation as a set of ordered pairs that we could graph. We could also express it as a table. And if we have a list of ordered pairs, or we have a table, we could graph each of those values. So remember, the first value is the left or right. So if I'm graphing 1, 5, I'm going to the right 1 and up 5, and that doesn't actually fit on my graph. Then the point 2, 4, to the right 2, up 4, to the right 3, up 3, to the right 4, up 2. And that second one is not in the right place. Let's try that again. There we go. So we could represent them as a table. We could represent our relation as a graph. Notice I'm not connecting these dots because there's no second and a half place. There's no 3.5 place. There's a first place, a second place, a third place, and a fourth place. And what we're talking about here is some discrete numbers, which just means not all the numbers in between, not everything between 1 and 2, but exactly 1, exactly 2, exactly 3, exactly 4. So discrete numbers are going to be listed. The last way we could represent, and this is really less common in math and more common when we're talking about relations between things in other courses, maybe history, sciences, but a mapping takes the values of your domain, 1, 2, 3, 4, or the first values, and maps them over to the second values, 5, 4, 3, 2, 1. And this should all technically fit inside this little mapping. And then it shows that relation by drawing an arrow from the first to the second item. And that 4 looks like a -1. There we go. So these are discrete numbers, discrete sets of relations, because we are listing finite numbers like just 1, just 2, just 3, just 4 for the rankings, just 5, 4, 3, 2, 1 for the amount of points that you get. And we can represent those using a set of ordered pairs, using a table, using a graph, or using a mapping. And again, we're really not going to talk about mapping much in this class. Now let's get into the idea of domain and range. And math people really like things to be in order. Domain is all of the x's of a relation, all of the x values or all of the inputs. Range is all of the y values or all of the outputs. So something a lot of people have trouble remembering which one goes where. Well, D comes before R in the alphabet and X comes before Y. So domain goes with X and Y goes with range. If we're talking about a function, or if we're talking about something continuous, then we're not just going to list the ordered pairs. We're actually going to use the interval notation that we learned in Unit 2 to talk about our domain and range, and I'm going to show you that. The very last thing, and probably one of the most important things we're going to talk about in this unit, is a function. A function is a special kind of relation in which each input or each domain value or each x goes to exactly one range value, exactly one y value. So something I want you to think about, and maybe this is going to age me a little bit here, but a vending machine is a great example of a function. A vending machine only takes certain kind of money. Like, for example, most vending machines don't take pennies. If you try and put a penny in, it doesn't work. But if you put in the right kind of money and you push the appropriate button, like right now I could go for a Snickers. If I put in my money and I push the button for Snickers, out pops one Snicker. And that is an example of a function. I push one button and one thing comes out. I put one x value in and one y value comes out. That's what makes something a function. Now, there could be multiple buttons on the vending machine that have a Snickers spot, right? I could push the first button or the second button and maybe both of those will send a Snickers out. That's still a function because what happens? I push the button and one thing comes out. It's not a function when I push the button and two things comes out. That would be a very broken vending machine. In fact, when I was in high school, we used to have a Gatorade machine in the girls' locker room, and there was one light blue Gatorade button, and if you pushed it hard enough in the corner, for whatever reason, it would spit out two Gatorades. So you'd put your dollar in, you would hit that button in the corner in just the right spot, and out would pop two Gatorades. And that was not functional. It was not a functioning Gatorade machine, and we definitely exploited it and took advantage of the fact that it was broken. But the key thing I want you to realize is a function means for every x, for every button I push, exactly one thing comes out. And that's what a function is. And think about it like a vending machine. It's functional. It does what it's supposed to do. One thing in, one thing out. At some point in time, you learned about functions and you talked about them in terms of a graph, and you learned something called the vertical line test. And the vertical line test says if I have a graph of something, like let's say this was my graph, it is a function if I can draw a vertical line anywhere along the function and it only touches the function at one point. So this would be a function. But if I had something like this would not be a function because it's touching at 2 points when I draw a vertical line. Because again, that vertical line is representing the x, and we're saying x only touches the function once. Every button push, every x has exactly one output. So this would be a function, but this second one would not be a function. So we're really going to focus on how do we identify the domain and range, and how do we tell whether or not something is a function? And all we're going to do in the rest of this lesson is really look at examples of those ideas. So this first example looks an awful lot like the one up top where we were talking about the place that you come in a track meet and the number of points that you get. And the directions here say express the relation as a table and a mapping, identify the domain and range, and state if it's a function. So let's first, just for each of these problems, let's represent it as a table and as a mapping. We could also represent it as a graph, but the directions aren't asking us to plot those ordered pairs. So I'm going to start by making a table. I'm going to have my x's on one side. I'm going to have my y's on the other side. Under x, I'm going to list all my x's. So all of my x's are all of my first values. 1, 2, 3. 1, 2, 3. When I push the 1 button on the vending machine, I get a 3. So 1 and 3 are going to go next to each other. When I push the 2 button on the vending machine, I get a 4. When I push the 3 button on the vending machine, I get a 3. Go ahead and pause this video and do the same thing on problem number 2. So my domain are all of my x's, -1, 0, and there are actually 2 zeros. And my range is all of my y's, -2, -1, and 0. So -2 goes with -1. 0 goes with, -1 goes with -2 for the y value. 0 goes with -1, and 0 goes with 0. So that's how we take the ordered pairs and represent them as a table. For a mapping, it's going to be set up really similar to a table in the sense that we're going to have our domain or our x values in one part of the circle, and we're going to draw arrows going to the y part of the circle. There is one big difference. So here I'm going to list 1, 2, 3. And over here I'm going to list -1 and 0. So I'm not going to list 0 twice when I'm creating a mapping, because the one thing that mappings really help do is identify if something is a function or not. So if you repeat an x value, obviously it's not going to be a function, because that means when I push 0 on the vending machine on number 2, it's actually going to 2 different places. It's like my broken Gatorade machine. It's sending out a -1 and it's sending out a 0, and that makes it not functional. That makes it not a function. So when you're going to write your domain in the left-hand part of the mapping, you're going to write your range in the right-hand part of the mapping, and you're not going to repeat any values. So here I have 3, 4, and -1. Over here I have -2, -1, and 0. And then we're going to draw an arrow saying 1 goes to 3. When I push 1, I get 3. When I push 2, I get 4. When I push 3, I get -1. Over here, when I push 1, I get -2. When I push 0, I get two things. I get -1 and I get 0. So right here is that indicator this is not a function because 0 is going to two different places. And the mapping is really the easiest way to see that. It's shooting itself off into two different directions. And that makes it not a function. So both examples 1 and 2 are examples of discrete sets because they are just the numbers 1, 2, 3, 3, 4, 1 for the first one. So when we list our domain for discrete numbers, we're just going to use set notation and list those numbers from smallest to largest. So 1, 2, and 3. When we list or when we have discrete values or a list of numbers for our range, we're just going to list them again from smallest to largest, -1, 3, and 4. Go ahead and pause the video and identify the domain and range on number 2. So the domain on number 2 is going to be 0, -1. And actually, I just did not write that in numerical order, did I? That should say -1, 0. The range, because we're listing smallest to largest, is -2, -1, and 0. So the very last thing this question asks is it a function? So number 1, yes, it is a function because each number, each domain value goes to exactly one range value. Number 2 is not a function, and the reason it's not a function is 0. 0 is going to two places. It's going to -1 and it's going to 0. So this doesn't ask you to explain, but if you were asked to explain, the reason it's not a function is because of the number 0. 0 is broken. It goes to two different places. So I actually want you to pause this video and go down to number 4. Number 4 looks most like what we just did. Identify the domain and range on number 4 and whether or not it's a function. So pause the video and do number 4. So the domain are all of those x's, 1, 4, 8. The range are all of the y's, 1 and 4. And again, I'm not going to repeat 1, even though 1 repeats. So now we have to ask ourselves, is this a function? So looking at our x's, do we have the same number repeating in our x's, or do we have an x that goes to two different y's? And no, we do not. So yes, this is a function. So something you're probably thinking is, wait a second, there's two y's that are 1, but that's okay. When I push x equals 1, I get 1. When I push x equals 8, I get 1. So that again is like having two different buttons on the vending machine that give you the same thing, right? The vending machines are stocked with the things that people want the most. So sometimes there are two different buttons to push that give you the same candy. So yes, this is a function. The x's are not allowed to repeat, but the y's are allowed to repeat. So looking at the rest of these examples, these look very different. We're not just listing numbers anymore. If you look at number 3 is a segment. It's a piece of a line. So the domain isn't just 1, 2, 3, 4, 5. It's every number between 1 and 5. So think back to Unit 2. This is saying our domain, and when we're looking at our domain, we're looking at the x side. What is the furthest left that this graph ever goes? Because remember, we're going to use interval notation since we're not just listing numbers. And when we do that, we always have the smallest value on the left. Well, the smallest value is right here, and that's 1. The largest value is over here, and that's 5. Now, are the circles on the ends open or closed? They're both closed, so this is going to be square brackets. So again, this is very different than when we're just listing a bunch of numbers. Now we're talking about a continuous function, something that you trace from left to right without lifting your pencil. When we were talking about a set of ordered pairs, those are dots. We would be lifting our pencil every time. So now we're going to look at the range. The range is talking about the y's. So again, the smallest y graphically is the lowest value this graph ever goes. So the lowest it ever goes is right here. That's the lowest it ever goes is 3. The highest it ever goes is right above that, 4. Again, those are filled in circles. So those are going to be square brackets with 3 and 4. So domain, furthest to the leftmost value, the rightmost value. Range, the lowest value, the highest value. And then this is a function. It passes the vertical line test. If I draw a vertical line, it would only touch my graph one time. Let's look at number 5. Something to notice about number 5, and I'm going to make them a little darker, is that there's arrows on the ends of both sides of the function. What that means is this function is going forever and ever and ever in both directions. So the domain, it's going forever left, because as this keeps going down, 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 it's going to forever go to the left. That means it's going to negative infinity. It's also going forever to the right, because there's arrows on the ends. It's never going to stop. It's going to keep going out, 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 out. Similarly, the range is talking about up and down. How far down is it going? Well, this arrow says it's going down forever. Down forever means negative infinity. And this arrow says it's going up forever. Up forever means positive infinity. To check if it's a function, we're looking at the vertical line test. Each of those vertical lines that I just drew only touched the function once, so that means yes, it is in fact a function. Okay, number 6, let's talk about domain first. Looking at this graph, and actually I'm going to go down here. Looking at this graph, what is the furthest left it ever goes? It goes left until it gets to that point right there. And that point is closed, and that number is 1. The furthest to the left it ever goes is 1. Those arrows are saying it goes to the right forever. It's going forever this way, up and down, but forever to the right. Now thinking about the range, it's going down forever, so negative infinity, and it's going up forever, positive infinity. Every single y value will be covered since there are arrows on the ends. Okay, we're going to look at the last graph before we come back to number 7, because I want to just kind of keep going on the same type of problem. So, number 8, let's look at the domain. Well, over here it's going left forever. I need to check what's happening along the curve. So it's going left forever, so I know negative infinity is going to be the first part of my domain. Now I'm going to trace my function. Something weird happens when I get to 1. When I get to 1, it like jumps up. But can x be 1? Yes. Okay, so now I'm going to look at the second piece of my function. It's going from 1 to 2, so I've covered everything there, and then it jumps, and it jumps down, but that's okay. Then it's going forever out. So asking yourself this question, is there a value of x that is not covered somewhere? The left piece covers everything from negative infinity to 1. The middle piece covers everything between 1 and 2. And the last piece covers everything from 2 up. So this is everything. We've covered everything. That's going to be negative infinity to infinity. And this is by far the most challenging one on here. This is called a piecewise function because there are multiple pieces making up the graph. Well, I guess it's called a piecewise graph. We haven't established whether or not it's a function yet. The range, it's definitely going up forever. It's going up forever there and up forever there. It looks like, so because of that, I can say it's going, looking at this one, it's going from 0 up forever. Does this graph ever go below 0? No, there's no y values underneath the x-axis. So this is going from 0 up forever, and it does look like it touches 0, so we're going to put a square bracket there. Is this a function? So let me erase what I have drawn on the graph to see that. Does it pass the vertical line test? Or a better question, is there anywhere where it doesn't? Over here it passes the vertical line test. Over here it passes the vertical line test. But right here, it does not. This is not a function, or I'm just going to say no, because when x equals 1, there are 2 different y values. X equals 1 is the broken part. Okay, last but not least, we're going to look at a function, and this is really stretching anything today. So if this is the only one you don't understand, that's okay. And don't worry, we're going to do more examples in class. I know this is challenging, and I know it's important for every future math class that you're going to take. Even in calculus, we talk about the domain and range of functions. So y equals 2x. So think about for yourself, the domain is talking about x's. Is there any reason that I couldn't plug in a negative number? What happens if I plug in a negative number? 2 times a negative number. That's allowed. I'm not like taking the square root of a negative thing. I'm not doing something mathematically illegal. So I'm allowed to plug in all the negative numbers. Can I plug in 0? Sure. 2 times 0 is 0. I'm allowed to plug in 0. Can I plug in positive numbers? 3, 5, 7, 1,000? Yes. So the domain here is everything. In next unit, we're going to talk about how this is actually a graph and the domain, or a line, and the domain of every line is going to be negative infinity to infinity. And then we're going to talk about range. Whoops, I flipped the colors. That's better. Range. If I plug in a negative number, can I get a negative number? Yes. If I plug in a negative number, or if I plug in 0, can I get 0? Yes. If I plug in a positive number, can I get a positive number? Yes. So I'm allowed to plug anything in, and I'm allowed to get any type of number out. So that means everything for both the domain and range. Both the domain and range are all real numbers. Is this a function? Yes. No matter what x I plug in, there will only be one y value. And I actually skipped number 6. Number 6 is not a function. It doesn't pass the vertical line test. So the key things to recap today. A relation is just a comparison of two things. A relationship between two things. A function is a special kind of relation in which each input or each domain value or each x goes to exactly one y. So make sure you're asking yourself, is this a broken vending machine or is this a working vending machine when you're thinking through that? The domain are all of the x values, and if that's a continuous function, not just a list of numbers, then that's going to be represented using interval notation. If that is a list of numbers, a discrete function or a discrete relationship that we're looking at, you're going to represent it using set notation. I hope that this video helped you get an intro into domain and range, and we will be doing much more practice with it in class. Thanks for listening.